This video is on the first and zeroth law of thermodynamics. Question 1. Define thermodynamics. Thermodynamics is the branch of physics which deals with the relationships between heat and other forms of energy. Question 2. Define a closed system. In a closed system, no mass can be transferred in or out of the system, but energy can be transferred as heat or work. Question 3. Define an isolated system. In an isolated system, no mass and no energy can be transferred in or out of a closed system. Question 4. State the first law of thermodynamics. The amount of energy added to a system is equal to the sum of its increase in heat energy and the work done on the system. The first law is an example of the principle of conservation of energy. Question 5. Consider a system filled with an ideal gas and the equation for the law of conservation of energy. Q equals delta U plus W. Define delta U. What is the meaning of delta U is greater than 0, equal to 0, or less than 0 joules? So delta U is a change in internal energy of the gas in the closed system. So if delta U is greater than 0 joules, then the internal energy of the gas in the closed system increases. So internal energy means the speed, temperature, and average kinetic energy of the gas. If delta U is equal to 0 joules, then the internal energy of the gas in the system remains the same. Internal energy being speed, temperature, and average kinetic energy. Remember, the meaning of temperature is average kinetic energy. And average kinetic energy depends on the speed. So speed, temperature, and average kinetic energy have a very close relationship with each other. If delta U is less than 0 joules, then the internal energy of the gas in the closed system decreases. So when we think of a closed system, we think of a box increasing or decreasing its volume. And we also think of a piston, this black disc moving to the right or left, where the volume inside increases or decreases. Define W. Okay, what's the meaning if W is greater than 0, equal to 0, or less than 0 joules? So work is done when we move an object. Work is Fs cosine theta. So if W is greater than 0, then work is done by the gas and the volume increases in that closed system. If W is equal to 0, then no work is done on or by the gas in the closed system and the volume of the closed system remains unchanged. If W is less than 0 joules, then work is done on the gases in the closed system and the volume of the system decreases. So once again, work is greater than 0, volume increases. Remember the word is done by the gas. If work is less than 0, the volume decreases. Work is done on the gas in the closed system. Part C, define Q. What is the meaning if Q is greater than 0 joules, equal to 0 joules, or less than 0 joules? Q is the amount of energy entering or leaving the system. So, if Q is greater than 0, then the internal energy delta U of the gas in the closed system will increase and or the volume of the closed system, W, will increase. So for example, we can put a small fire below the closed system to increase the temperature and therefore the average kinetic energy of the gas inside the closed system. Okay. Here are some examples. If we keep the volume of the closed system to be fixed, then the internal energy of the gas in the closed system will increase only if we put that small fire under that volume. If we keep the volume of the closed system to vary, then it's possible that the volume of the closed system will increase only and the internal energy delta U of the gas in the closed system will not change. And then it's possible that both the internal energy of the gas in the closed system and the volume can increase. So if Q gets bigger, then both delta U and W could get bigger, or just one of them, while the other one remains zero. If Q is equal to 0 joules, then there is no change in energy. So imagine a closed system which has a really excited high energy gas which is fixed by a pin, so its volume is constant. Now we remove the pin. The internal energy delta U of the gas in the closed system will decrease, while the volume in the closed system, which is directly proportional to the work done, W, will increase. Now if Q is less than 0 joules, then the internal energy delta U of the gas in the closed system will decrease, and or the volume of the closed system will decrease. We can put ice around the closed system to decrease the temperature and therefore the average kinetic energy of the particles inside the closed system. So example, if we keep the volume of the closed system to be fixed, then the internal energy delta U of the closed system will decrease only. So in this example here, imagine putting ice around this closed system so it gets colder, temperature decreases of the gas inside the volume, but the volume is the same. Here's another example. The internal energy delta U and the volume both decrease. So definitely you need to conceptualize when each one of these three variables is greater than 0, equal to 0, or less than 0. Question 6. 8.42 times 10 to the 3 joules of heat is given to a closed system while the system does 4.37 to the 3 joules of work. What is the change in internal energy of the system during this process? So we start with this equation. It says change in internal energy, so just solve for U. This is the amount of work done. This is how much energy was given to the system. So this is what we have here. And the closed system increases its volume, because it says a closed system does this much work. Question 7. A closed system absorbs 2.33 times 10 to the 3 joules, and at the same time 1.24 times 10 to the 3 joules of work is done on it. What is a change in internal energy of the system during this process? Okay. So it says change in internal energy. So we solve for delta U. Okay. The work was done on it. So you notice this has a minus W and there's 2 negative signs here. So that's why our answer is positive. And the closed system compresses. Question 8. 9.997 times 10 to the 3 joules is removed from a gas held at a constant volume. It says constant volume, so the work done on it is 0. What is a change in internal energy of the system during this process? Well, this is removed. Energy is removed. So it's going to get colder. So that's why this answer is negative. Question 9. 246 joules of thermal energy is used to compress a gas. Compress a gas means work is negative, right? While its internal energy increases by 122 joules. Determine the amount of energy leaving the system, okay? The internal energy increases, so delta U is positive, 122. This compresses a gas, so the volume gets smaller, so the work is negative. Question 10. In a slow isothermal compression, 3.45 times 10 to the 4 joules of work is done on an ideal gas. Determine the work done on the gas. It says isothermal. That means temperature is constant. So delta U is 0. If temperature is constant, kinetic energy is constant, average speed is constant. Okay? It says compression, so work is going to be negative. So delta U is 0, work is negative, so Q has to be negative. Question 11. During a slow isothermal expansion, okay, constant temperature and work is positive because it says expansion. Okay. 3.45 times 10 to the 4 joules of work is done by an ideal gas. Determine the work done by the gas. Here we go. So you can see 10 and 11 are like the opposite. Question 12. Describe the equation W equals P delta V. If there is a constant pressure, then the work done is by the gas. If W is greater than 0 joules, the volume of the container will increase. If there's a constant pressure, then work is done on the gas. W is less than 0. The volume of the container will decrease. The area under pressure versus volume graph tells us the work done by or on the system, since the units of pressure times volume is force per unit area times volume equals joules. So this is a pressure versus volume graph, and the volume will increase. Look at this red line here. That's constant pressure. We also call that isobaric. Question 13. An ideal gas in a piston is compressed from an initial volume of 1.87 times 10 to the minus 1 meters cubed to a final volume of 1.03 times 10 to the 1 meters cubed. Okay. It's compressed, so the volume decreases at a constant pressure of 4.04 times 10 to the 5 pascals. The initial temperature of the ideal gas before expansion is 406 K. Determine the work done on the ideal gas and the final temperature of the ideal gas. So W equals P delta V, because it says constant pressure. We know delta V because they gave it to us. And we know P because they gave it to us. So we were able to solve for W is negative. Of course it's negative because the volume is compressed. So PV equals nRT, P1 equals P2, N1 equals N2, R equals R, of course. So we have this equation. And we're given the initial temperature. So the question asks us to solve for the work done on the ideal gas, which we did, and the temperature of the ideal gas, which we also did. So we answered the questions. Same question. An ideal gas in a piston is expanded from an initial volume of 9.87 times 10 to the minus 1 meters cubed to a final volume of 1.23 times 10 to the 0 meters cubed at a constant pressure of 3.03 times 10 to the 5 pascals. The initial temperature of the ideal gas before expansion is 398 K. Determine the work done by the ideal gas and the final temperature of the ideal gas. So first they want the work done by the ideal gas. It's expanded, so W should be positive. Okay. It says constant pressure, so we're going to use this equation. And we know delta V is positive, so W is positive. Then we could use this equation, and we learned this from our previous video about ideal gases to find the final temperature. Question 15, describe the equation U equals 3/2 nk sub b delta T, which is also equal to 3/2 nr delta T. So the change in internal energy of an ideal gas is given by this equation. If the temperature of the container which contains the ideal gases increases, then the internal energy will also increase. Question 16, define thermal equilibrium. Thermal equilibrium occurs when two objects have the same temperature. Okay. Question 17, state the zeroth law of thermodynamics. If object A is in thermal equilibrium with object B, and if object B is in thermal equilibrium with object C, then object A is in thermal equilibrium with object C. Question 18, what does the area under a pressure volume curve tell us? The area under a pressure versus volume curve tells us the work done by or on the system. Part A, define isothermal process. Draw 3 isothermal processes or isotherms on a pressure versus volume graph. An isothermal process is a process in which the temperature stays constant. This process needs to happen as slow as possible. So if delta T is 0, then delta U is 0. So Q equals W. Okay. So remember PV equals nRT. So if the right-hand side nRT is constant, then if P gets bigger, V gets smaller. So these 3 purple lines are isotherms. Because P gets bigger, V gets smaller. Part B, define isobaric process. Draw an isobaric process on a pressure versus volume graph. An isobaric process is a process in which the pressure stays constant. This is also a slow process. So remember this equation. Then we could put it into this equation. So work is equal to delta U plus P delta V. That's only if it's isobaric. So an isobaric process is a horizontal line in a pressure versus volume graph. Part C, define isochoric or isovolumetric process. Draw an isochoric or isovolumetric process on a pressure versus volume diagram. An isochoric or isovolumetric process is a process in which the volume stays constant. You can heat up or cool down the closed system and keep the volume constant. So W equals 0 joules. So Q equals delta U. And here we have that vertical line, constant volume. Part D, define adiabatic process. Draw an adiabatic process on a pressure versus volume graph. An adiabatic process is a process in which no energy enters or leaves the system. This process needs to happen as fast as possible. So Q is equal to 0. So delta U plus W is 0. If the system expands, then W is greater than 0 and delta U is less than 0. If the system contracts, then W is less than 0 and delta U is greater than 0. So adiabatic is this red curve here. Okay? Red curve is adiabatic. We go from one temperature to another temperature. Question 19. A gas does 1,000 joules of work while a closed system expands adiabatically. Determine the change in internal energy. It says adiabatically, so we know Q is equal to 0. Okay. And the closed system expands, so W is positive. Okay. Let's think. A gas does 1. Okay. Question 20. 1.23 times 10 to the 3 joules of work is done on a closed system during an adiabatic compression. Determine the change in internal energy. So it says adiabatic. So we know Q is equal to 0. So delta U equals minus W. And these two negatives make a positive. And in 19, we're solving for delta U. So this minus W is going to be minus this. So this is actually a positive number, but the negative sign makes it negative.